Good evening, everyone, and welcome to SocialFlight Live. I'm Jeff Simon. We have a wonderful show for you this evening. I'm so excited. Before we get started, I just want to do a couple quick housekeeping notes. As always, tonight's broadcast will be recorded and available on our YouTube channel. Just search for SocialFlight, one word, SocialFlight on YouTube. And of course, as always, go check out socialflight.com and the free SocialFlight mobile apps for Apple and Android devices. Tens of thousands of aviation events and destinations, and still a few days left, basically 1 week left, before we give away our next prize in the Fly to Win Challenge, a custom pair of Flying Eyes eyewear. So be sure to check that out. And we're just constantly having prizes through there. We are just here to support general aviation and also to support you at home. We understand, of course, that these are challenging times. We started the show at the beginning of the pandemic, and we're just going to continue it and keep it going because we're here to bring inspirational people to you to help fill your evening and connect you to other pilots. I think it's really, really important. We have such a strong community, but it's also a fragile community. And it's important that we all stay together, that we keep each other flying. We encourage that. We encourage proficiency and keep as many people employed and going within this world of ours in aviation as possible. And so I encourage all of you, make sure, especially as the weather starts to change over time and things like that, get out there, fly, do whatever you can, support your local FBO, your local airport, restaurants, organizations, etc. And even though there are fewer in-person events as there have been in the past, search them out. Go on there, check out SocialFlight, find out where someone has gone to the trouble of having an in-person event. It's challenging on all of these people, and it really, really helps to show them that you appreciate that and that you've made it to that fly-in or that pancake breakfast or that Young Eagles event out there. And so I would just encourage you to do that. It's certainly something that we are doing here. And calling you here from Boston, we finally have the hurricane that has passed through, and we will be able to fly again now that the weather and the skies have cleared. So with that, I'd like to talk about tonight's guest. Ric Peri is Vice President of Government and Industry Affairs at AEA, which is the Aircraft Electronics Association. Ric is a career aviator with over 45 years of experience in aircraft maintenance and operations. His work for AEA involves advocacy, consulting, communications, and working closely with the international government entities such as the FAA, EASA, and others. As an accomplished writer, educator, and facilitator, Ric's written over 200 articles, conducted thousands of hours of training, and facilitated over 25 years of industry meetings, conferences, and forums. If you've seen him speak, it is truly a wonderful opportunity to just soak up all that knowledge, and it is like drinking from a fire hose. I'll tell you that Ric has also been a personal mentor of mine for many years. He's taught me the finer points of FAA regulations, and more importantly, how to understand the intent of the regulations so that I can apply it with my own work as an A&P, as an IA, as an author with AOPA, and so many other things that I do. And so as we turn this on here, bring Ric on, I am thrilled that he's here tonight to take us behind the scenes of the avionics and that world that we all fly behind. Welcome, Ric. How are you doing?
You know, I was doing really well until you did the introduction. I have no idea how to live up to that expectation, but you know, thank you for it. My mother really thanks you for it.
Maybe it's just like attribution. I'm giving you these traits so that you continue to improve over time. In all seriousness, thank you so much. I appreciate you coming on the show, and a personal thank you because you have, very, very seriously, been a mentor of mine and taught me so many different topics. And so it would be very easy for us to spend an entire hour off on random subjects, but I really, really want to get your knowledge and talk to you tonight about avionics in particular, what's happened in the past, and what has caused some of these like big changes. Because when I reached out to you to come on this show, one of the things I said to you was I wanted to talk about the revolutions that have happened in avionics whether that be GPS or whether moving map or all of a sudden all these things that used to be experimental coming into the panel.
Right.
And you stopped me. So take it from there.
Sure. Well, so, and I actually spent, a number of days after we had talked thinking about that. And I think it's both, interestingly enough, because we are having a revolution of information that's being brought into the cockpit. And, I'm coming up on 50 years next year in maintenance. And when you look at this, and from what I started with 50 years ago to what we have today, the amount of information, the pilot situational awareness is unprecedented at the GA level. And, going back to your time with Bendix and Honeywell and the companies in the past, it wasn't, 3 decades ago, where all of the products that we were dealing with were what I call top-down introduced. They were introduced in the military, or they were introduced at the airline level. And then as they were developed, they slowly migrated into business aircraft. And then if we were really, really lucky, we might end up with a few strands in general aviation. And then about, 2.5, 3 decades ago, we ended up with Intel and all these other Silicon Valley companies who were starting to produce things like this. And we were able to introduce small computers into the experimental aircraft. And then we saw a philosophical change as technology evolved into allowing smaller and smaller platforms. We started to see a philosophical shift to where avionics now was being introduced in the experimental community and in the garages and in the shops and the back rooms, and growing into aviation and into general aviation. And honestly, an upward mobility in those products.
Mm-hmm.
And that's where we really are starting to see things. And part of the reason that I remind people that it truly is evolutionary. Okay. In the commercial aviation environment, we have Autoland, right? And we've had Autoland for a couple of decades. When was the first documented Autoland aircraft demonstrated?
You got me.
1937. Okay, it was actually a Fokker, and so you look at this, you're saying, okay, well, that's 80 years of progression. That's 80 years of evolution to where the technology is finally allowing those technologies, those concepts, to migrate into general aviation aircraft and providing that revolutionary effect that you're talking about. It's a huge element to it.
So let me interject on that a little bit, because it obviously puts a smirk on my face that that's how long ago that something was actually autolanded, and that technology actually existed in some form back then. But the big questions I think that you have good answers to, that most people ask here on the consumer end of this, are, why is it so hard? Why is it so hard to take that technology from other platforms, or even in the beginning, talk about the GPS revolution and where that came from? Why is it so hard to get it into general aviation? And why is it so expensive That seems like that's the number one thing on people's minds, and hopefully it's starting to change some. But I think understanding, if we go back in time, when those first GPSs came out, as little as they were doing, they were really expensive too, and they took a really long time to get certified. So tell me how this works. Explain this to everybody.
Okay, so, well, let's step back to 1937 and move forward. You know, it took 80 years for the computer industry or the digital technology industry to be able to create the chips and the servos and everything else in such small platforms that they were a viable product into our light GA aircraft. So from a technology perspective, we've really only been dealing with probably about 2 decades, about 20 years. Now, years ago, I asked that very question. I said, why is it every year I'm seeing a new portable piece of equipment introduced, and yet, you know, it's so many years before I see a certified? I don't understand. Tell me, you know, what's the answer? And I was told, and it was a random number, but I was told that basically it's 6 years from design to certification. And it's simply a matter of validating that it won't do any harm to your existing aircraft. Okay? And it is the certification standards, and it's the validation. And in many cases, when we approach something with this revolutionary mindset, which is where our conversation started, when you introduce this to a safety bureaucracy and say, hey, I've got this revolutionary thing that's going to solve world hunger. Wait a minute. What do you mean revolutionary? And it's not until you actually start digging into it that you find out that it's, from a technology perspective, it's actually an evolution. It's just the next step in the evolution of these products. And so we're really certifying a legacy concept in a modern environment. And so from certification and engineering, in many cases, it's evolutionary, whereas from marketing and sales, it's revolutionary. Mm-hmm. And we end up in this spiral in this process. But the bottom line is, it just takes a long time to validate software, to validate hardware, to get mean time between failure. All of these things that are required to meet the certification standards. Back again, going back to you know, when we were much younger in the industry, a lot of the products that we produced in GA were actually certified as a function of the aircraft. Mm-hmm. So if I look at my Cessna or your Beech, many of the components inside that aircraft were actually approved via the TC rather than some independent TSO or PMA, right? And so there wasn't this double certification process. Now, it drove us to buying all of our replacement parts from Beech or from Cessna, but nonetheless, the aircraft itself was type certificated as a whole.
So let me interject for a second. You're talking about like when there were like Cessna branded autopilots or radios or things like that. Is that what you're talking about?
Or the KX-170B.
Oh, so that was part of an aircraft before it was part.
It never had independent approval.
Oh, okay.
Okay. So a lot of the products back then didn't have that. And so it wasn't until, I don't know, and it's a random date, you know, 20 years ago, maybe 30, where manufacturers started requiring their suppliers to start having pedigree or approval for those parts. And so it got into the habit that everything had TSO. And when we were dealing with legacy products, that was fine. An altimeter's an altimeter's an altimeter. It didn't make a lot of difference. So, you know, whether the altimeter was made for a 172 or an altimeter was made for a 737 really didn't matter a whole lot. When we started getting into electronics, it made a big difference, because in the case of electronics, the validation of software and the electronics piece of it is very, very time consuming and costly. And so when you look at TSO, TSO is designed for the greatest application.
Can you explain to everyone what TSO is?
Technical standard order. It's a parts pedigree, okay? And when we look at this technical standard order that is managed by the FAA, it is a very broad-based standard. If you want to build X, this is the standard you build it to, and then when you build it, you can install it in any aircraft that uses that kind of a part. Well, in legacy avionics, it didn't matter much. In a normal printed circuit board radio, it didn't matter much. In steam gauges, it didn't matter much. Moving into software-driven components, it mattered a lot, and it drove the cost right out the top. And so that's what you were seeing as you were going through the certification process of the early generation products. We've got general aviation companies coming to the marketplace where you have all of the big names in commercial aviation are well versed in how to show compliance. We've got startup companies at the other end that don't have the history, they don't have the background, and it becomes a very slow, methodical, and expensive process to certify a component. And so 6 years is not unusual at all.
Right. And it seems a lot of companies where it was longer. I mean, the challenge as just someone, a pilot out there, is, you know, you go to AirVenture, you go to Oshkosh, you look around, you see some wonderful things through the years that have come out. And I will admit, I've been in the booth staffing those things where the display everyone's working on is being run by a PC in the background, and there's no real product there yet.
Right.
And it's not, it seems it's not fair almost to the public to show these things, to say this is coming, to put a price tag on it, and then year after year after year go by before they actually make it. That's hard, and then it's also hard how unfathomably expensive some of these are. Now, we've seen a lot of changes, but we're not necessarily seeing changes across the board. It seems like we're seeing changes start to happen with some newer products. So what's changed more recently that's affecting companies' ability to bring things into the cockpit, certified avionics, less expensive?
So what you're seeing is a result of the Part 23 rewrite. So we spent a 10-year episode rewriting Part 23 to make sure that it was performance-based. But one of the major things that came out of that was two realizations. The first one was the applicant has the ability to apply other standards than what we traditionally have used. So for a lot of avionics, we use RTCA standards. RTCA is a standards body that for a long time had a very tight relationship with the FAA. And recently they lost that capabilities, but they're a standard body. They produce standards, typically DOX, 178 for software, 160 for environment, but it's a standards body. And so most of the TSOs reference an RTCA standard. So everybody's very comfortable with that. Part 23 comes around and says, whoa, wait a minute, we can have other standards. We can use ASTM, we can use ANSI, we can use, you know, these various options and SAE. And so what happens is that it's highlighted this and it's allowed people to identify standards that are better applicable to their products. When you look at the traditional RTCA standards, they're designed for a clean sheet product. I'm going to build an aviation widget. And so, great. From the design stage outward, those standards from RTCA are excellent. They work very, very well. But if I wanted to take and bridge a product that was built for the experimental market and bridge it into Part 23, those standards don't work real well. You almost have to reverse engineer the product all the way through. And that's what we wanted to get away from. And so we ended up with ASTM standards that allow for the validation of a system. And what you saw going back to Experimental Aircraft Association, the EAA STC, to install the Dynon D10 in the aircraft. That EAA used ASTM standards to validate that the Dynon was good enough for its intended installation.
Okay.
They didn't certify it to a Boeing and Airbus airplane.
Right.
They certified it to the Cessna 172s that it was intended to be installed in, right? And
Yep.
that's the big difference, is that we really got this philosophy that said, I can certify to the intended market rather than some hypothetical broad-based application in aviation.
Right.
And that's where you saw this next generation of products come in with PMA, Parts Manufacturing Authority. And
so let's put some examples to that, because that really makes sense, right? I mean, if you go back, you don't have to go back far until you're looking at like where some of the greatest advances have been, of course, like primary displays, where you've got Garmin G500, G600, what, $20,000 or more, you know, $20,000, $30,000 for a display in front of you. And then the next revolution, the next evolution that comes after that, that's huge for the market, was Aspen coming out with these gorgeous displays that were modular and you could get for a third of that price all of a sudden.
Right.
And get in your panel and do even more features than that. Now all of a sudden there's this breed, as you mentioned, of products coming on that are $2,000. That
Yep.
I mean, and that is that the regulatory changes in the approach to it that you're describing?
Right. So when you look at things like the G500 and 600, the 500 in particular, you can put that in a class 4, which is a large Part 23 aircraft, all the way downward compatible. I can put Aspen in King Airs all the way down through the process. But I've got these new products that were certified from the bottom up, and they were certified for these 200,000 existing piston engine aircraft. And you know, that's their market. They weren't trying to produce a product for King Airs. They were trying to produce a product for the smaller 4 and 6 place piston aircraft that date back to the car days, the civil aeronautics regulations.
Right.
And that's the transition. So we're starting to see products with a targeted market rather than a huge broad-based market.
So let's look forward a little bit into some of the areas that have been left behind, I think, by this. And I'd love to get your thoughts on that, because clearly we've had some amazing advancement in the areas of primary displays. The FAA seems to, through these regulations, have yielded a little bit, stepped back and said, okay, if you're going to look at if you're using this for which way is up and whatever, it's got to be better than a vacuum system. So they're starting to kind of finally cry uncle, and we can get cheap things there. To me, one of the tougher areas, at least for IFR pilots out there, are actual navigators. Those where you actually put in a flight, you know, an IFR flight plan, fly approaches, do things like that. It seems like we have Garmin, we have Avidyne, and I don't know if we have anybody else that's selling a system that you can fly and approach. You can display it, like we've said, but actually do these. Those are still tens of thousands of dollars, or in some cases maybe as low as maybe 10,000, but big money.
Mhm.
What do you see? What's our future in that area? Is that something that we can be optimistic about? Oh God, I didn't stump you, did I?
No, but I think the challenge is it goes to a question that you had earlier. Why is it so expensive? Okay. And I'm reminded of a conversation I had with a writer from the Smithsonian Magazine. And he had attended a conference on drones. And one of the gentlemen from one of the companies, rather large Silicon Valley company, was giving his presentation and hinted that they may build ADS-B modules. And so this writer calls me and says, "Hey, I heard this company's talking about building modules. What would that do for the industry?" And I thought for a second. So we have about 200,000 registered piston aircraft in this country, about 6,000 commercial aircraft, and about 15 or 18,000 business aircraft. So all told, we have about 350,000 aircraft. Okay. If every aircraft could use 2 of these modules, because you got to have redundancy, right? So every aircraft has 2 of these modules. The entire life cycle sales would be less than Apple's first day sale of the iPad.
Okay.
It's a numbers game. Okay. It
Okay.
costs millions of dollars to certify a product, and the largest single product that I'm aware of was 60,000 units. So you've got to amortize that R&D and certification cost over 60,000 units.
Okay, but let me put my optimist hat on and push a little bit on that one,
Okay.
because one of the things that we've seen affect this market has been the drone market or the UAV market or whatever the next flavor of what we call them is going to be, because I'm
Yep.
dating myself when I say UAV. But this is certainly has affected transponder technology and ADS-B technology and things like that. One of the things that I don't hear much about, but clearly, obviously, the companies have to tackle and are tackling probably, is navigation, though. I mean, these drones still have to navigate over distances
Mm-hmm.
that is not direct distance, that is
Mm-hmm.
obstacle avoiding, that is they're not hitting each other and whatever, but not just by see and avoid, but if we really are moving to a world of millions and millions of drones taking flight in the airspace or just below it, but having to even navigate in their own world. Um, doesn't that technology of navigation have to somehow come down about how you get to a place, how you navigate, and can't that help us?
Well, if you're talking about a GPS chip, sure, but
Hmm,
they're not using the same navigation system we are.
right. But
I was just,
you don't see that the concepts of FMSs, flight management systems, or flight plans, you don't see us getting. I'm trying to hope that we get rescued somehow from
well,
the $10 and $20,000 navigator.
I think some of the challenges, and I don't want to go into the regulation too much on what are the requirements for a navigator, because that gets me in trouble every time I go down that path. I will tell you that we have a tendency to over-regulate ourselves, okay, in many cases. In the case of simple navigation, simple GPS, simple VOR, in a VFR aircraft, yeah, I expect to see prices continue to erode over time, because I think the technology is going to bring it around. I think we're seeing a lot of technology improvements in light GA, but again, it's a very limited market. So moving something out of a non-certified drone world, which is no different than moving it out of an experimental world, bringing it in and having to have it certified is going to be challenging, and it's going to be costly, and there's not going to be a lot of market to distribute that cost over.
Mm-hmm.
And that's what, I mean, it's you know, this isn't an FAA industry thing. This isn't an avionics versus, you know, aviation thing. This is business 101.
Mm-hmm.
You've got to amortize the cost of your raw materials somehow. And when we talk about, you know, the largest single avionics radio sale product was 60,000 units. It was a first. We'd never been there before.
Mm-hmm.
And we haven't been there since.
Right.
And so, you know, and then the other thing is that, you know, what year's your airplane?
75.
75. So it's coming up on what, 45 years old, 46 years old?
Doesn't look a day over 20.
But yet, if it was on the street, it would have historical plates on it, right?
Exactly.
And so we don't have turnover in aviation like we do in the consumer world. Okay? You know, how old is your cell phone? 2 years, 3 years?
Right.
You know, we in consumer products, we've got a high turnover. Even in the automotive industry, you know, the vast majority of Americans anyway, you know, they're turning cars over every 4 or 5 years. And so, you know, that mindset keeps the price of a lot of consumer products down because there's that much volume. In aviation, you're flying a 45-year-old airplane. Mine's a 59. You know, and still solid, you know. And when you look at the marketplace and you look at like the Gamma report on new sales, you know, we're replacing the general aviation fleet of aircraft. We got 210, I think. Where's my notes here? I think we have 210,000 airplanes, and we're replacing them at between 1,000 and 1,500 airplanes a year.
Right. So I think that the bottom line is we're not going to get rescued on things that are, the more aviation specific they are, the less likely we're going to get rescued. And so when you start talking about rescued by the commercial market, rescued by having something that upends things, I mean, the last thing the last two things, like we said, were displays and ADS-B because of the opportunity there. So let's set aside, all right, you're right, we're not gonna get another, you know, GPS IFR navigator for, you know, $1,000, but what are the things that are coming? What are the things that then that the regulations that you're seeing on your side are going to allow to happen in the cockpit, so that the entrepreneurs who want to throw good money after bad, but will benefit all of us, will take advantage of?
Well, I think first of all, and I think you missed one of the major products, and that is the autopilots.
Absolutely, good point.
Autopilot technologies that have been introduced in the last 3 or 4 years are unbelievable, driving the price down significantly. Honeywell has and I'm going to use entry-level product, even if it gets me in trouble, But I think Honeywell has a great product to introduce with that, with their acquisition of TrueTrack.
Yep.
And I think Garmin's got a fabulous product with their GNC 500. Both of those are designed arguably for the entry-level aircraft. It's got the price point down to where it's manageable. It's a limited market, and if you get into more complex aircraft, into more complex systems, you get into Genesis and some of the other systems out there. But we're seeing a lot of the auto flight technologies really advancing, and I think you're going to continue to see that growth coming out of exactly what you were talking about, the unmanned world of drones, as well as the eVTOLs and the products that are being developed for autonomous flight and stuff like that. All of the name brand avionics manufacturers are all working on autonomous flight. And so you're seeing that cross-pollinating of products, and we're going to continue to see those products being introduced. They're not going to be dirt cheap. We're not going to see, coming out the bottom, but where you can use a commercial product and bring it into aviation, then we can see a distinct improvement in cost. And, if you've been to Oshkosh this year, you saw the MyGoFlight heads-up repeater that they have. Phenomenal technology, but it's effectively automotive technology brought into aviation. And it is what I see as exactly what you're asking for. What are we going to see coming through into the marketplace? If you look at the latest cars, the LiDAR systems that the cars have in tracking and stuff like that, there's going to be an application in aviation where we're able to take that technology and bring it into aviation. And the price point for that will not be as high as aviation designed and built products.
Tell me a little bit about that, and so people understand the LiDAR technology you're referring to.
Well, the LiDAR technology is the radar system that you see that the cars are using all around the bumpers and everything else. They got the little sensors that keep them in the line and, rattle your steering wheel when you start to drift a little bit. And, the little hand comes up out of the dash when you're getting sleepy and slaps you across the face and wakes you up a little bit. You're seeing those technologies, and there's going to be applications for those technologies in aviation.
Right.
And we're going to see people predominantly coming into the experimental community, but you're going to see that bridge continue to grow between the experimental products into at least class 1 and 2 on the certified aircraft. Now, when you start getting into more advanced flight operations, it starts getting more complicated. Because now I need the reliability to actually hit my numbers when I'm flying IMC. Well, if I'm using an automotive part, I may and may not be able to demonstrate that. And that's where I start to see that bridge between intended purpose of the product.
Right. So what I'm hearing from you, and what also seems to be what we've seen in the marketplace, is that there's both an opportunity as well as some flexibility from the FAA in things that are, let's say, safety and emergency oriented, as opposed to like routine operations, right? Like when we started talking about, flight management stuff and navigating, that we didn't seem to be able to have a lot of opportunity there. But if we're talking about see and avoid systems that are used in cars to keep you in a lane, or like this auto land systems that have come out that have to do with, hey, well, the alternative is you're going to crash. So
Right.
These are things that you're expecting to see new starting to come out, and maybe for more aircraft.
Absolutely. It was a growing number. It's kind of funny. I challenged one of the manufacturers, and I said, God, I love this little multi-function display you had 20 years ago. And why aren't you building it? He said, why should I build it? And the fact is that a lot of our multifunction display functionality has been replaced with an electronic flight bag.
Mm-hmm.
And, those are the things that are really driving a lot of the safety enhancements. CFIT, controlled flight into terrain, was the #1 cause of fatal accidents in general aviation, I don't know, 10, 15 years ago. It's not even on the top 10 list anymore.
Mm-hmm.
Because we have moving map displays that give the pilot situational awareness when they're flying.
Yep.
And it's that type of technology that's making aviation safer.
Right.
But it's also making it more fun.
Yeah.
And that's the other piece to this is that you've got to keep the fun factor in here. And I think that's the part that's always challenging with this. We get very, technical on, nav comms and stuff like this. And yeah, they're expensive. I can't argue that. But, your plane is a 75. And how many nav comms has that airplane had in its life?
Not a ton.
3, maybe?
Oh,
Maybe.
You don't know me. Come on, it's had 6.
Okay, but it was a demonstration airplane for a lot of years. So. But that's exactly it, And so on the things that aren't turned over very often, I don't think you're going to see a lot of relief. And those things, especially they're used for critical flight operations, I don't think you're going to see a lot of relief in those products.
Right.
But on the other hand, you are seeing a lot of relief on, as you said, safety enhancements.
Yeah.
There's a whole generation of, I think you called them primary flight displays, but they're technically electronic instruments. We're seeing a whole slew of those coming into the marketplace because the FAA stepped up and said, removing a legacy vacuum pump driven instrument and replacing it with electronic is a safety improvement that we're willing to approve. And they made a policy document. In most cases, it's a minor alteration. And you can install these things in these airplanes, get away from the very low mean time between failure gyro instruments, and upgrade to electronic instruments, completely enhance safety at a price point that's a couple $1,000. Mm-hmm. It's hard to beat that.
Yeah. Yeah. And you get obviously an inside peek. I mean, I can't, I like when you say unnamed instruments that have sold certain numbers. Obviously you get an inside peek with a lot of these companies into what they're doing, what they're working on, what's coming out in some cases. Can you give us any kind of other hints about really what's coming in general?
I wish I could. And it's not that I'm sworn to secrecy. I am.
No, it's not that you'd have to kill each and every one of us after you told us.
No, and I mean, when I talk with my members, I have an implied NDA with all of them, non-disclosure, right? However, none of them talk about what they're working on behind those curtains. And it's I mean, I have had FAA sponsored meetings when we wrote the advisory circular for AML STCs. We had all the manufacturers at the table, and AEA actually hosted the meetings. We had everybody at the table, and they all sat there on their hands and wouldn't discuss what the next generation products were because everybody else was in the room.
Right.
They don't.
Right.
What's being done in R&D stays in R&D. They don't share that information.
So let's poke at it ourselves then. I mean, I want to merge your insight in your knowledge with maybe the things that we are both aircraft owners, we're both pilots, the things that we would like to actually start to see and try to see what happens. I know one of them, the other night, I was flying at night, I was flying with my sons, and you know, we were talking about, as we often do, going through what would happen, what would we do if. And night flying seems, especially in single engine aircraft, but night flying has always been problematic for those of us living in parts of the country with very few good places to land. During the day, maybe it's easy to find a farmer's field in the middle of a forest where there's trees everywhere, but or mountains, where all the different places. I have to believe that the commercial technology that's on the market has solutions for this to guide people to places to land other than airports. And you haven't seen anything in that regard. Do you see that coming in the horizon?
Well, I was going to say that I believe one of the manufacturers just introduced that product at Oshkosh.
Well, yes, I'm aware of that one. I'm actually talking about finding a field, not like where could you glide to
Right.
in
No,
general, like
got
not like what your glide range is. I'm saying we have satellite photography, you know, imagery. We have so many. We know where the buildings are, where the parking lots are, where the racetrack is, where the highway is. No manufacturer I'm aware of has come out and said, I'm going to use all this knowledge that we have to help you find that best solution when there are no good solutions. But like you said, Autoland, we just said before, is a product of not just the technology being there, but a willingness to approve it because of the alternative.
So there's two things that come to mind. And one is and it would take the EFB pilot app world to do it, but to be able to take the chart and go to satellite view, just like we do with Google Maps right now.
Mm-hmm.
Okay, so part of that answer is to have a manufacturer who could take their moving map display, whether it be on an iPad or a multifunction display, and be able to revert to a satellite view. And then there already is a number of infrared and camera systems, low-cost infrared camera systems available that allow you to see in the dark.
Mm-hmm.
I don't think from a product liability perspective, you could see anybody who said, go land in that field, because first of all, the day after they put that algorithm in their instrument, the farmer plowed the field in the opposite direction, right?
Of course.
You know, and so
I mean, and satellite images aren't necessarily, you know, new or whatever, but it doesn't even have to be at night. It's just this idea.
oh yeah,
You know, is this where it's really the question. That was just one idea. It's really the question, though, of where do you think, where's the next surprise is going to be? Where's the next, you know, jaw drops going to be that can help us?
I think you're going to see a continuation of integration in the cockpit. I think that what you're going to see, that we've seen this last couple of years, where we're giving the pilot more and more tools to help them make better decisions. Okay, I think we're going to continue to see that. I think we're going to continue to see the integration of, honestly, what you're asking for, where we're seeing altitude warnings and airspeed warnings and items like that. Personally, I would like to see advancements forward of the firewall instead of just behind the firewall. You know, I think forward of the firewall is the Achilles heel in the vast majority of general aviation. And the reality is, is that there's a lot of technology that could make that better.
Mm-hmm.
But the certification reliability that the FAA is holding everybody to makes a lot of those new products cost prohibitive and painful to get certified. And I think that's the challenge.
So why is that? I mean, aviation, avionics for general aviation, as we've been talking about for this hour, has had tons of evolution, and you hit it right on the head. Forward of the firewall hasn't really had tons of evolution. What's been holding that back, and is there any way you think the FAA is going to change that?
I don't think the FAA is going to change it without congressional help. I think that, you know, the incidents of engine failure and lawsuits, I mean, it kind of goes back to the General Aviation Revitalization Act, the GARA, back when Congress had put some limitations on liability insurance, liability lawsuits. I think a lot of that is triggering it. You know, we got a lot of ambulance chasers that love aviation, and I think that in and of itself is a challenge. I mean, we're flying 50-year-old technology, 60-year-old, 70-year-old technology forward of the firewall that I don't know that I've ever had in a car, and yet it's like, yeah, well, that's the way it's supposed to be. Well, it doesn't have to be that way. I know that we've got new technology in fuel sending. We actually, as crazy as this sounds, we actually have the ability to have accurate fuel gauges in our airplane. The technology exists, and you know, and it's funny because at Oshkosh I was talking with the company. And I never have been able to pronounce it. CEIS, C-E-I-S, I think.
Yeah, yes, yeah.
And I was talking with them, and it's like, well, yeah, you know, the FAA wants to go back and certify it as new. I got the worst piece of garbage in my airplane. I mean, I've got 60-year-old floats, and you've got a digital replacement, and they want to hold you to the original equipment certification? Seriously? And it's that kind of philosophy that I know leadership in the FAA really wants to change the paradigm. They want to move forward. They want to get these safety enhancing products into the hands of us pilots. The challenge is that their policies and guidance and the instructions that the field engineers are dealing with haven't caught up with the demand and desires of the leadership. And so until leadership puts their vision into paper and into the hand of the field engineers, we're going to continue to struggle with the challenges that we have.
So what have you been doing lately? What's in your you know in your work with the government, your work with the FAA, the types of things that are happening? What are we likely to see? We've seen a lot of supplemental things, right? Someone just wrote in about angle of attack systems. We've now seen primary displays, sorry, flight instruments that have come up. Not a ton with radios. ICOM came out with some stuff that was newer than what people had, but what do you think? What's coming, and what are you doing these days?
Well, so I'm spending a lot of time in the maintenance regulations. We know Part 145 is going through a rulemaking committee right now. I'm quite involved in that one. I co-chair that committee looking at repair stations and the operations of repair stations. We know the FAA is working on Mosaic, which is a mega rulemaking modernization of aircraft certification. We heard it introduced at AirVenture a couple years ago with a lot of fanfare about how it was going to change light sport aircraft and the experimental aircraft market and all of that, it since has been, my words, hijacked a bit, because Congress had mandated that the FAA do some rulemaking on the certification of drones. And so now the drones have been incorporated into that rulemaking as well. I understand that there's some flight standards initiatives that have gone into that as well. And so that is a big rulemaking that not only I'm keeping in track of, but I encourage your audience to keep track of, because that's going to have a major effect on all of us moving forward. The proposal will be out, scheduled to be out the second quarter of next year when it's available for public comment. There's a number of initiatives, the light sport aircraft and kind of updating that standard. There's a proposal to talk about a new personal aircraft category, which is going to create some opportunities to put some of the technologies that you're talking about into aircraft, which will be pretty nice, simplify things. There's an ASTM standard that came out last year. Can't remember the number off the top of my head, on the evaluation of alterations, a determination of major minor.
Mm-hmm.
In that standard is a checklist for making a determination of major minor. That is been deemed by the agency to be an acceptable means of compliance to make a determination of major minor. And so we now have tools to make that determination. By all rights, it should drive a lot of these installations into a minor alteration, where people have been hesitant to determine something was a minor alteration because of fear of retribution.
Mm-hmm.
This standard gives them the ability to have an analytical approach to major minor, and to have a defendable answer that they can move forward with. And hopefully it can simplify installation of a lot of the avionics equipment we're talking about.
That would be great. I know, you know, as we approach the top of the hour, some of the questions that we've gotten in have really been about the accessibility for so many people with aircraft that maybe aren't the typical 172 out there, that have been left behind, from autopilots, from navigators, from like whatever types of systems, but basically are not in many cases, they feel like they don't have a basis for how they're going to upgrade their Swift or their Navion or whatever they have, their trailercraft. Because as you've said before, it's all a numbers game, and the companies are not going to make an investment there. So what hope is there for those folks?
I think you're starting to see products coming to the marketplace that really is targeted on that. And it's my understanding that Mosaic in particular may provide some relief for those aircraft. I fall in that category myself, having a straight tail 172. Most of the STCs start at the slant tail and really don't go backwards because the flight control systems are different. So, you know, there is a lot of that, but I see relief on the horizon. I know the FAA wants to provide relief for those aircraft. And I think that there's an opportunity in many cases that you can make the application. One of the things that we don't do very well is ask. Okay, we may ask our inspector, we may ask our buddy down at the FSDO, we may ask a friend of a friend, but we don't formally ask the administrator. And that's, if there was one shortcoming, that's the shortcoming. We can take a product, show similarity, show compatibility, show where it's fit, form, function, applicability, and appropriate. the field employees of the FAA are not empowered to approve it. Okay, but that doesn't mean the FAA is not empowered to approve it. And so we recognize that, hey, I understand you're not authorized to approve this. I appreciate that. But I want to run it up the flagpole and get an official denial from headquarters before I give up.
Right.
And I think that's the thing that we don't do enough of. The ASTM standard for alterations is F3361. F3361. Standard guide for classifying alterations for in-service aircraft under FAA authority. And the FAA has deemed that as an acceptable means of compliance. So arguably it's the same thing as an AC.
Yep. So one last thing while I still have you here. And this also comes from something that was on my list, and I've also seen people ask directly here. If there's one area of our technology that does not seem to have evolved, it is our communications, right? I mean, I know pretty much most of the airports around here, my area, all use 122.8. We all listen to the wobble. We can all talk over each other. Do you see anything coming anytime soon that's going to change this part of our world?
Well, I think once you get above our aircraft, you know, they use digital communications. And the FAA intentionally has not mandated it. But if you're going into a major airport, you can use digital communications for clearances and everything else if your aircraft is equipped with it. So the towers and ground is capable of supporting you.
At the major airports, at least.
At the major airports, but I don't know that anybody has built and I'll say small simply because we don't have a big footprint, a small certified unit to be able to communicate with ATC in a small aircraft. The FAA intentionally did not mandate it because of, among other things, they had just finished mandating ADS-B, and they weren't going to mandate a new product for general aviation. But
well, it doesn't have to be a mandate, but wouldn't it be great if for some very low cost, he said loudly and clearly,
sure.
For some very low cost that you were able to optionally put it in your aircraft and optionally get flight following or clearances or approaches or whatever you needed to, and no longer was it ready to copy or you know, a pen and pencil on your knee, but all of a sudden it was going into your navigator. Is that in our future?
Actually, I think some of it is. I think that voice to text is a very real technology that exists today, and I've seen products that you know do voice to text, so it's still coming in on voice, but it's being text onto a display. And like I said, in the business aircraft, they have it. But I think for the most part, if you were to put that in your airplane right now, you'd lose a seat. The products just aren't small enough yet. And I think part of it is that, you know, if you get away from a primary flight display system, we're just not putting multifunction displays in airplanes. We're using iPads. And, you know, certifying a tablet for something as critical as clearances and stuff like that, it's impossible because you don't control the software to make sure it happens.
Okay, but okay, and this is worth going over for a few minutes here, but that's a perfect example. Why does it have to be certified, right? Couldn't you have that? Couldn't you be sitting there as long as the commercial world out there gets us communication? Let's just assume you have communication somehow, and data in your cockpit. If you had that, really, it's just the communication. Really, it's just, we know we can file a flight plan electronically that way. So wouldn't it be great to have a means of communicating for the rest of it, not just
Sure.
filing with flight ops, but some type of communication that allowed that?
Don't disagree. But if your voice to text system, for whatever it's worth, takes 260 and makes it 206, that could be a problem. And
Yes, of course,
well,
certainly.
and
But
so
that's a problem for the pilot who had to review it before it sent it out to ATC.
and that's the whole thing is that if you look at all of the filing flight plans that we do today, it requires the pilot action to accept it. And the reverse is true. So when you get data into the cockpit, it still requires the pilot to accept it before it goes into your navigator. The technology is there, making it small enough and affordable for GA. There may be a product out there that I'm not aware of, but there's only one or two if there is.
Yeah,
And I
it
think the
seems to me,
challenge is that
it's more regulatory almost than anything else, because it seems to me that if we had, again, either satellite or you were within cell data range, it seems to me that if I had a way, I know that a Leidos will send me your flight plan has been activated or your flight plan has been canceled. So I know I get that. It'd be
sure.
wonderful to get that data from them that tells them, hey, here's your new ATC instruction, review it and acknowledge it, or something like that. And then I can always press a button from there, and companies have already come up with ways of getting that into my navigator.
So the good news is, again, this goes back to this whole conversation we've had for this hour. So I was at AUVSI last week, which is the autonomous conference down in Atlanta. And one of the presenters was one of the major telephone companies. And they were talking about their ability to broadcast 5G vertically to manage drones.
Nice.
I would suggest to you, we very well may have 5G in the cockpit doing data communications sooner rather than later.
Well, that would be a great thing and a nice optimistic point to end on, Rick.
I'm always optimistic.
Absolutely. So, Rick, I just want to thank you so much for taking your time to join us this evening. I hope you will come back and we will talk some more about what might be happening in the future or comment on some new development in the industry. I really do appreciate your time and your insight.
It's my pleasure.
And to all of you out there, again, thank you so much for taking time to join us here on Social Flight Live this evening. Appreciate it. Certainly, of course, we went over a little bit tonight. Really do appreciate your time and everything that you do to support general aviation. We will be back next week, Tuesday, August 31st, as always at 8 p.m. Eastern Time. We have Vic Syracuse here with us. We're going to talk about all sorts of things with the experimental aviation market, what it's like to get out there and buy your own experimental aircraft, even if you don't want to build it. And then we're on the September 7th, the week after that, Brian Schiff is back, and we will be talking about the possible turn, not the impossible turn, but what his techniques are to be able to do that turn back should you encounter an engine failure or other emergency right after takeoff. After that, Pete Bunce of Gamma the week after that. And finally, on the 21st of September, Captain Gary Dyson of Orbis will be with us. And so again, thank you so much for joining us this evening. I'm Jeff Simon. I wish you all blue skies.